let's look at an integral where I have the other kind of problem with infinity. So rather than trying to integrate x across the whole axis, I'm going to take just a regular interval. My interval today will be between 3 and 5. So this is where I'm trying to integrate. The function that I'm integrating is f of x equals 1 divided by x minus 3, that whole quantity to the power 1/3. Or if you prefer, it's 1 divided by the cube root of x minus 3. So when I write this formula, I need to bear in mind that this function is approaching positive infinity from the right as I get to the value x equals positive 3. So that could pose a problem. Now, again, like I was doing for my previous lecture, I've asked Desmos to calculate this integral for me. And so long as the lower bound is not equal to 3, we can just use an antiderivative. And the fundamental theorem of calculus lets us calculate the area of this region that's marked in green. So here at a equals 4, Desmos has calculated this integral to say that we get 0.881. And I can take smaller values of that lower bound, and you can see that I'm picking up more area here. And Desmos now tells me that the integral is representing 1.54, if I round, units of area. As I move my slider to the left, I am picking up more and more area here. And if I get it to a equals 3, now this is the region that I have covered. And Desmos claims that there is 2.38 units of area highlighted in green there. This little spike is shooting off towards infinity. So I want to talk about how we will actually calculate these out and figure out these values when we're working on these problems ourselves. Now, if I had a different function here, let's change the formula for f of x. So no longer 1 divided by x minus 3 to the power 1/3. I'll take 1 divided by x minus 3 to the power 1.1. So the graph of the function looks similar. I no longer have this curve existing to the left of x equals 3, but that's okay. That's not where I'm integrating anyway. I can do my same slider trick where I am highlighting some of this region. When x equals 4, I can calculate this antiderivative and do my fundamental theorem of calculus, and I should get about 0.67 as the amount of area highlighted in green here. But now, as I move the slider to the left, I get more area. So there's 1 unit of area. Here's 2 units of area. Here's 3, and so on. And if I go all the way, it's a little bit difficult here because I can only get so small on this slider. If I went all the way to a equals 3, Desmos is telling me that this integral is undefined. So what was it about this integrand being having a different exponent here? If I have an exponent of 1/3, the integral exists. If I have an exponent of 1.1, the integral does not exist. How do we know that's happening, and how do we verify that for ourselves?